Okay, today for lesson two, we are introducing proportional relationships with tables. This is just like the same way that we use tables when we were talking about scale factor in the last unit. And I think today you're going to see a lot of similarities between what we had been doing with scale factor, with scale copies, and how that kind of ties into what we're talking about now, which is proportional relationships. That should be a phrase you're familiar with from our last unit, and we're going to continue that idea. Now, looking at our goals, we need to know about equivalent ratios today, and I hope that you already have a pretty good idea about that from our last unit. And also, we're going to use tables to reason about two quantities in proportional relationships. So we're just going to organize our information in those tables instead of creating all those proportions where we're putting those ratios equal to one another. If you're paying attention and if you've been paying attention, what you're going to start seeing very soon is that we've already done this. And this is a lot of repetition just with a new idea. We're not talking about scaled copies anymore. Now we're just relating other things in these proportions. So, our first activity called feeding a crowd says a recipe says that 2 cups of dry rice will serve 6 people. Complete the table as you answer the questions. So the first part asks, how many people will 10 cups of rice serve? Let's look at the table here. So already we have the ratio that we were given in the situation. 2 cups of dry rice will serve 6 people. All right, I can see that there. I can also see another ratio showing 3 cups of rice will serve 9 people. All right, now the question asks, how many people will 10 cups of rice serve? Here, I can see that we are increasing this original amount to a lot more rice. This is kind of going along with doubling or tripling a recipe where everything has to increase at the same rate. The same thing is happening here. If we increase the amount of rice, the number of people being fed will go up. So, one thing that would be interesting to know is, what does 1 cup of rice serve? And that could certainly be some helpful information here. If 2 cups of rice serve 6 people, half that amount of rice should serve half that number of people. That would mean 1 cup of rice should serve 3 people, and that would be a good piece of information. 1 cup rice for 3 people. All right, we can use that as we go forward. We can also use the ratios here to form equivalent ratios. So if I'm going to take this original amount of rice, 2 cups, and turn it into 10 cups, that's increasing 5 times. So that means if I have 5 times the amount of rice, I should be able to serve 5 times that amount of people, or 30 people. All right, now let's look at the next ratio. So that answered part A. Part B wants to know how many cups of rice are needed to serve 45 people. So now we're working sort of backwards in our ratio. We're given the number of people. We need to know how much rice we'll need to cook. So I don't see an easy way to turn this original ratio of 2 cups of rice to 6 people into 45. 6 doesn't evenly go into 45. So that could be why they gave us this other second ratio of 3 cups of rice to 9 people, because 9 does evenly turn into 45 if we multiply by 5. And to do the same with the amount of rice, that means I'm going to need 15 cups of rice to do that. Now, hopefully you see that tie-in to what we were doing with scale factor. One side of the figure increased by an amount, the scale factor, and so we had to do the same to the other side to keep it a scaled copy. Here we're just keeping a scaled copy of rice and people. All right, let's look at the number of spring rolls. So we're given a recipe that says 6 spring rolls will serve 3 people. Complete the table. All right, here's what I notice. I notice that it's going to take more than 1 spring roll to feed a person. It's actually going to take 2 spring rolls to feed each person because 6 spring rolls feeds half that number of people. So again, that could be something useful, knowing that 2 spring rolls feeds 1 person. Okay? Now I can also do the same type of idea that I did here in the first table. So I'm going to be increasing these quantities as we go up. I'm getting 5 times the number of spring rolls here. 6 times 5 is 30. So that should feed 5 times as many people. So I'll multiply by 5 there. That means 15 people will eat with 30 spring rolls. Okay, now I'm also going to be looking at that comparison here back and forth. So I can't easily turn one of these numbers into 40. So this is where some more patterns are going to come in handy. So I know that the number of people being fed is half of the number of spring rolls. It stayed true here. And it's also going to continue on because these are all proportional. So 40 spring rolls should feed half that many people since everyone's going to be getting 2. So 40 spring rolls should feed 20 people. If I go the other way now, because I'm given 28 people needing to eat, that's going to require twice as many spring rolls. So instead of looking at this as being half the number of spring rolls, I'm going to look this way at doubling. Notice the reciprocals, 1/2 and 2 are reciprocals and are sending us opposite directions in our table. So 28 people are going to need 56 spring rolls in order for them to all eat twice the number. Now let's look at the next activity. So making bread dough. This again goes back to that increasing and decreasing a recipe. It has to stay proportional or we're not going to have a recipe that tastes the same. The bread's going to taste different or it's not going to cook right. So it tells us that a bakery uses 8 tablespoons of honey for every 10 cups of flour to make bread dough. And I can see that here as the first ratio here in the table. Some days they bake bigger batches and some days they bake smaller batches, but they always use the same ratio of honey to flour. Complete the table to answer the questions. And the first question asks, how many cups of flour do they use with 20 tablespoons of honey? So our next ratio here is what needs to be completed. All right, this would be a great time to figure out that that unit rate. We just did that on this last example when we found that 2 spring rolls feeds 1 person, comparing to that 1 person. Now we're looking at, hey, go ahead.
I'm sorry.
That's all right.
One of the students' computers is dying and nobody else has a charger.
Oh.
Could they, I mean, is yours charged fully?
Yeah, you can use mine.
I'll take care of it.
Thank you.
This test says 1/7 through 11. That's the right one, right?
That's the one. Yeah,
Okay.
it's not doing too much with the first ones that we already quizzed on.
Okay.
So.
Okay.
Okay, I appreciate it. Thank you. Nope, no problem. Okay, so we're going to take a look here at finding a unit rate. So I know, and you'll probably remember doing this when we were finding the scale factor, but I know that it's going to take 10 cups of flour for 8 tablespoons of honey. Now I can make that into a unit rate where I'm figuring out 1 tablespoon of honey would require how much flour. And this is just a division problem to find that unit rate. 10 divided by 8. So we can think of this as a division sign there. 10 divided by 8 is going to simplify down to 5 over 4, 5 to 4. And so my unit rate is going to be 5/4 cups flour for 1 tablespoon of honey. Now, if you actually divide it on your calculator, you probably got a decimal, and 10 divided by 8 is 1.25. That's okay too. That's going to work just fine. It's the same amount of flour, whether we write it as an improper fraction or a decimal, for 1 tablespoon of honey. All right, so every tablespoon of honey needs 5/4 cup of flour. 20 tablespoons of honey is going to require 20 times more flour than we have here in our unit rate. And remember, this is a unit rate right there. A unit rate's always comparing to one quantity. So the easiest way to solve this would be to multiply that unit rate times 20. So we're going to increase this 20 times, and that's going to require 25 cups of flour. I would do the exact same thing here. So I would take the 13 tablespoons of honey and multiply by my unit rate. This is what we used to call a scale factor when we were talking about scale copies. So we multiply by 5/4, and we would require 16.25 or 16¼ cups of flour. Now, each of these quantities just increased by the same amount. The honey just increased by 5/4, or that, again, as a decimal, 1.25. To go the other direction now, we're given the amount of flour. We want to know how much honey. I'm going to multiply by the reciprocal. I'm going to multiply by 4/5, which is why I kept that as an improper fraction. Trying to find the reciprocal of 1.25 is a lot harder. So don't be afraid of fractions. It's going to make this math a lot easier. So to find 4/5 of 20, to go backwards in this relationship, multiplying by that fraction is going to decrease the amount, which is what I want. The amount of honey is a smaller number than the amount of flour. All right, so 20 times 4/5 is 16. We're going to need 16 tablespoons of honey for 20 cups of flour to keep that batch of bread tasting the same. So we have already answered question 4, where it's asking what's the proportional relationship represented in this table. We're just going to write it out, but it's that unit rate that we just found. We're going to say that 1 tablespoon honey requires, or compared to 1 cup of, not 1 cup, excuse me, 5/4 of a cup of flour. That's that unit rate from the start of our problem. That is what that proportional relationship is. And we just looked at equivalent ratios to keep that same tasting bread, just in different quantities, different sizes. Okay, let's look at activity 4. So quarters and dimes, 4 quarters are equal to a value of 10 dimes. And we're going to look at that equivalent ratio. So obviously the values of those coins doesn't change, but if we need to represent more or less quarters or dimes, then we're going to change appropriately for the amount of the other coin. So the first question, how many dimes equal the value of 6 quarters? So we are looking here to increase the ratio that we were given to an equivalent ratio here. We can look at how this is increasing, and it is increasing by 1.5, by 1.5. So we can do the same here if we wanted. Okay, what it's going to lead us to eventually, though, is finding out how many dimes are equivalent to 1 quarter, because that would be our unit rate. This would be our unit rate would be here because we're comparing to 1 of something. And 1 quarter, which is 25 cents, is not going to be represented by a whole number of dimes. 2 dimes is 20 cents. 3 dimes is too much to equal the value of a quarter. So really, even though it seems kind of illogical, we need 2.5, 2.5 dimes to represent 1 quarter. So we can use our unit rate here. We can increase our ratio 1.5 times bigger because 6 is 1.5 times more than 4. So 15 is going to be 1.5 times more than 10. Or we can use our unit rate. If 1 quarter is 2.5 dimes, 14 quarters, each of them being 2.5 dimes, is going to get multiplied by 2.5. Okay, so using our unit rate here, we would find that we would need 22.5 dimes to be the same value as 14 quarters. All right, finally, we're talking about green paint and mixing that paint from blue and yellow paint, and we're trying to make a specific color of paint, so we have to keep our ratios equivalent. If we are going to use the original ratio, 2 cups of blue paint goes into the bucket and 10 cups of yellow paint. Now we're asked to find the next quantity here in the table. It says, how many cups of yellow paint should you mix with 1 cup of blue paint to make the same shade? Again, this is going to be our unit rate right here, because we're going to compare to 1 cup of blue paint instead of 2 cups like we were given originally. Well, there's a couple ways we can find that, but we're taking half the amount of blue paint, so we should take half the amount of yellow paint. So that should require 5 cups of yellow paint to make the same color, the same shade of green. You can also find this by taking our ratio and simplifying it. So if we had 10 cups of yellow to 2 cups of blue, we could divide 10 by 2, or we could simplify this by dividing both of these quantities by 2, and we would have 5 cups of yellow to 1 cup of blue right there. All right, then it says make a new pair of numbers that would make the same shade of green. All right, just for a challenge, I decided to use a decimal amount. So let's say I wanted to use 4.5 cups of blue paint. Each one of those cups is going to take 5 cups of yellow to mix with it. So I'm going to multiply by 5. 4.5 cups of blue times 5 is 22.5 cups of yellow paint. I just realized, can everybody go back for a second? I used the wrong number here in my example. I wrote down the number from this one. So would you cross out the number of dimes and make that 35? please. Everything else is correct there, so I apologize for that. Okay, now going to our last one. What is the proportional relationship represented by the table? We're going to take that unit rate and we're going to write it in here. So 1 cup of blue to 5 cups yellow is that proportional relationship that we're mirroring here. Now, here is the big question and something we are going to talk about a lot. What is the constant of proportionality? Okay, the constant of proportionality always comes from a unit rate. So we found our unit rate, 1 cup of blue paint to 2 cups of yellow paint, 5 cups of yellow paint. And the constant of proportionality is going to be how we relate those two quantities in our ratio. We're getting 5 times bigger. 1 times 5 is 5. 2 times 5 is 10. 4.5 times 5 is 22.5. Our constant of proportionality is 5. That's very important. You're going to become very familiar with that as we continue on. But just remember that the constant of proportionality comes from the unit rate and is how we relate the quantities in our ratio. Okay, that's it for today. We will continue the same idea of proportional relationships and constant of proportionality tomorrow with lesson 3.